Hey everyone, welcome to our first deep dive of Open Web Foundry 7. Today we're going to have Sam tell us a little bit more about Arweave and give us an overview of what's possible with the protocol. We'll also be having our first community spotlight this Friday at 12 p.m. Eastern Standard Time. And in this event, we'll be having Open Web Foundry alumni, important Arweave ecosystem projects, present tools that you can utilize for your own projects. So that's a really important session, so be sure not to miss it, because then you can talk to the founders in the mingle session afterwards. Anyways, without further ado, I'll let Sam take it away and tell us a little bit more about Arweave.
Okay, hey everyone. So I'm just going to share my screen here. Can you see this, Jesse? Okay, amazing. All right, well, thank you everyone for joining us today. Today I'm going to give an outline of what Arweave is and what the PermaWeb is, as well as why you might be interested in building on it and how you would go about doing that. I think that Arweave fills a very sort of, you say, underserved niche in the crypto ecosystem. There's a lot of applications or platforms that help you, that are built to help you create smart contract systems. But Arweave is, as far as I'm aware, the only platform that allows you to build full stack decentralized web applications. So that's everything from the UI to the database interactions, all the way through to user data itself. But we'll get into that. So first, there we go. What is Arweave? Well, Arweave is, in a simple sense, a global permanent hard drive. In order to make this work, we've taken a blockchain, which is kind of like that in the sense it's distributed around the world and it's permanent, but made it so that it scales to fit arbitrary amounts of data inside. We really mean arbitrary. The max block size for Arweave is 2 to the power 256 bytes minus 1, which is, I should check this, but it's almost certainly more atoms than there are in the universe. So the protocol scales extraordinarily well. We had like a 53 gigabyte block over the weekend, which I think is the largest blockchain block that's ever existed, and the network just doesn't flinch. Yes, so we've scaled it to fit arbitrary amounts of data inside, replaced the proof of work element that you would normally get with something like Bitcoin or present day Ethereum with useful work, which is the replication of that data that people add to the network. So how this functions is that when you want to make a guess to mine a candidate block into the network, instead of guessing a random number, hashing it, and then seeing if that satisfies difficulty, which is the general system that you would employ in a typical blockchain. Instead, you take a random number and you hash this in a very quick hash, specifically low compute operation, and that generates a random place in the network, a random byte number. And it says, hey, go get me that byte. And if you have that byte on your hard drive, then you can recall it and you can read it back, and then you can perform another quick hash and then check the output and say, hey, does this satisfy the difficulty? But if you don't have that byte, then you can't take part in the mining. And so you have to guess again at the beginning. And so now as a miner, you're incentivized to store as much of that data as you can to waste as few of those hashes as you can. Essentially, because of the trade-off between how much that hash takes, the amount of work that takes, versus finding the data on the disk, reading the data off the disk, and bringing it back into the CPU and performing that function on it. Yes, you're heavily incentivized to store as much data as you can and pay less attention to the hashing component, which is a typical proof of work. So what this does is it allows us to stochastically, so sort of randomly, if you will, check the availability of the network over time. Last time I did the sums, we were checking every single chunk in the network. I think it was about 30 times every time we mined a new block in the network, which happened every 2 minutes. So that's pretty cool. It's a system that incentivizes and kind of forces miners to check the validity and availability of the prior data in the network as part of the mining process. Okay, that's interesting. And helpful, because now you can scale on-chain storage to arbitrary sizes. But how do you incentivize people to take part in this? Like, how can you make permanent storage sustainable? And this is a problem to some extent for all blockchains, because blockchain is just an ever-growing ledger, which actually there's no incentive to store the old stuff. And so, yeah, this was a problem with all blockchain architectures, including Bitcoin even, except when you make it so that you can store arbitrary amounts of data inside, you scale up the level of that problem. And so we address this too with the creation of what we call an endowment. And basically the idea is when you store data in Arweave, you pay not just for the settlement of a transaction into a block or for the storage of that data for a short period of time with a specific miner. Instead, what you do is you pay for 200 years of storage at the present cost. Then as the cost of storage declines over time, that 200 years expands out. And when you work this out, what happens is as long as the cost of storage in any given year has declined at a higher rate than 0.5%, then you've ended up at the end of that year with more storage purchasing power than you had at the start. Kind of like an endowment in the traditional financial system. You would start one year with, I don't know, $10 million, and then you earn some interest on those dollars, you spend some of them, but you end up with more dollars at the end of the year than you had at the start. It's essentially the same system, just applied to storage. That makes the storage sound expensive, but actually storage is so cheap that this comes out to about, depending on the time you use the network, about 0.7 to 0.9 cents per megabyte, which for web applications or even tweets and this kind of thing is extremely cheap, particularly when you put it in perspective against smart contract chains. So that's how we solve the economic sustainability question around Arweave. So you add these two things together: arbitrarily scalable data storage, sustainable incentives to store that data over extremely long periods of time, hundreds or thousands of years, and that is Arweave. That's the permanent global hard drive. On top of this, we have the PermaWeb, which is all of that data inside Arweave accessible in people's web browsers. So the idea is that you can take any transaction ID from the network, which is the sort of unit of interaction, if you want, with the nodes, and then you can put this into a web browser and put it into a web browser associated with either an Arweave name resolution system, which some people have, or a gateway. So arweave.net/TXID, something like that, or arweave.live/TXID, or ar.io or gateway.ar.io, I think it is, /TXID. And you get the same data back from the network and rendered in your browser as if it was just a normal web page. And this enables us to create a permanent, decentralized web. Why would we want to do this? Well, the original vision of the web was to create humanity's collective, distributed knowledge graph, a place that we could contribute all of our understanding about the world and hyperlink, so reference between it, and create a knowledge base that was open for all people to access, hopefully across time at extremely low cost, if not no cost. But it's that middle part, actually, across time, which is where the web has failed. So the web self-evidently, I mean, we all went to gather.town, right, to join this call. The web has taken over the world. It is probably the most impactful technology created in the last 40 years, probably since the creation of the internet, right? It's a profound technology, but it does have this problem, which is that it has no built-in system of memory. When you commit knowledge to the network, we all know, and this is, I think, a testament to how prevalent the problem is, that the idea of a 404, which is actually a technical intricacy, right? That's the error code you get when a piece of data is not found on the web. Well, that is so common that it's entered the zeitgeist, right? And people that know nothing about computers will tell you, oh, I got a 404. Well, therein lies our problem. And the solution, we think, is the PermaWeb, which is a web that simply never forgets. So why would you build apps on top of this system? Well, one way to think about this is to see that actually what we're really talking about is storing knowledge for extremely long periods of time, like hundreds or thousands of years. Applications are essentially just knowledge for computers. They are, in the same way a piece of knowledge is an instruction or a sort of guide for how to achieve a task. So I might know how to cook an egg. Well, that's knowledge, right? But it is fundamentally some sort of process guidelines for how I achieve a task that I might want to achieve. Well, apps are essentially the same thing for computers. They allow us to instruct a computer on how to achieve a task, more or less. And we think that with that in mind, it makes just as much sense to store apps inside this system as it does knowledge for humans. It's just knowledge for different types of people and machines. And you could argue that we people are kind of machines as well. It's brains and machines. Okay, so why would you build an app on the system? Well, there's some sort of, I would say, philosophical reason, but there's much more concrete reasons too. Like, for example, you can build a web application with no controller. So the interesting thing about the PermaWeb is that while it's extremely simple in some sense, it's just permanent data storage. What that actually means in practice is very deep in a few different directions. One of which is that it changes the relationship of control between people and information. So once a piece of information is on the PermaWeb, nobody controls it. It's not like it's owned by someone with an NFT or something like this. It's always available to all people at essentially no cost across time, because you've already paid into the endowment, and that endowment contribution will pay for its storage. And there are various mechanisms we'll get onto later to incentivize access to the data, to delivery of the data to people. Well, this means that the web developer, that is you guys actually, doesn't have privileged access or control to the application. Once the application is out there, it is in the public commons, if you will. It is owned by everyone or nobody, which solves a sort of fundamental problem we see with big tech right now, which is that because of the structure of the web, that essentially every location you go to is on somebody else's private property. Well, you are accessing it at their behest. And I don't think that the big web companies in the sort of, the millennium, the sort of digital revolution that happened, I don't think they really wanted to accrue the power that came with that. I think that the early internet was made up of protocols, and everyone involved seemed pretty happy with that. But the problem was that the protocols at the time couldn't accrue value. There was no way of getting paid for your work. So I think one of the saddest stories here is that Tim Berners-Lee, who essentially created the web, made almost no money from it. And last year he sold an NFT, which was stored on Arweave, of the source code of the original web browser and web server that he built. And that was his way of monetizing it. He made like $1 million or something when he evidently created an industry that is at least tens of trillions of dollars, if not hundreds of trillions of dollars of value. So one way or another, people moved to creating companies rather than protocols. And in doing so, it meant that in cyberspace, we always access someone else's private property when we want to use a web app. So if you go to twitter.com or if you go to gather.town, actually, these are places owned by other people, and by law, they're able to do whatever they want there, which has led to a lot of the issues we see in society right now, because essentially it creates centralization of power with people that are only incentivized by financial gain when the services they offer are more or less public utilities. They are so vital to our world now that we really can't do without them. But because of the protocols, because of the way things developed, one way or another, they always ended up in the hands of private companies. And so we don't have any rights. And that leads to situations like this, where YouTube is talking about LGBTQ issues are demonetized. Well, YouTube is like a fundamental service that, I was going to say almost everyone. I guess there are some people in society that never use it, but very, very few. It's the way that people talk to each other on the internet in a properly conversational form, where you can see people's faces and then it's a discussion almost. Well, a private company is in control of that. And so we have no recourse when this type of things happen. Or, and arguably the other side of the political spectrum, well, I mean, that's debatable, I suppose, but nonetheless, when the Joe Rogan Experience is distributed through Spotify, well, they can just like delete his episodes, and he's only got like 1,600 episodes. They've deleted 10% or something like that. He has no recourse because this is a private company offering a service, and they can do by law exactly what they want. And Arguably, that is reasonable, but the problem is that we treat it like it is a public utility, yet it is provided by a private company. Well, no more. So if you want to, you can publish your podcasts. And I see TerraSpaces is here, which is interesting. But you can publish these podcasts onto a platform that is hosted on the PermaWeb, where it is permanently available. And so behind this permacast.dev URL that you see here, there's actually an Arweave.js ID. You can find that TX ID, and then you can put that into any gateway at any point in time and be presented with this exact same page. Nobody can change your access to it, which I think is an extremely powerful thing. Permacast runs fundamentally as a public utility, which, yeah, you just can't do that on the normal web. Like you have to, one way or another, be a private organization run by a select group of people. Or you can have applications that are controlled directly by their users. So you can essentially allow users to develop DAOs and have those DAOs govern the spaces that they operate in. And a way to think about this is, well, imagine you had like a subreddit where each of the members, as they gained karma, they gained voting power, and they could, vote on the kind of content that they want in their space or don't want in their space. But they are the sovereign unit of that space in cyberspace. They are the people that control it. There is no company that sits on top that is, essentially ruled by the profit motive alone, and the community is beholden to their whims, because they can change, as we've seen over time, on a day-to-day basis. So this is, pretty powerful, we think. And there are systems inside Arweave that allow you to do this in a sort of elegant way. Here is Antelia is a I think a kind of art auction house is the right way to put it, which is built on top of Arweave. Well, it has what we call a profit sharing community. We can get into that a little bit later, but one way or another, it's a way for their community to self-govern the application platform itself. The company that built the application is not a privileged party in the operation of the application itself. Okay, you can also build applications that users can trust in a deep way. So in the Web 2 application lifecycle, it essentially goes like this. A founder comes up with an amazing idea, either on a weekend or over a few months, something like this. They build out an MVP, they put it into the world, it's free. And everyone likes it, and they're suddenly seeing a huge amount of traffic, which is amazing. They also check their hosting bills, and they realize, oh, for every new user I get who is using the service for free, I get more costs, right? So my costs as the developer scale with the number of users I have. That's a huge problem. So you've got like two potential solutions if you find yourself in this situation. You can either hard monetize the application extremely quickly, shove ads everywhere, or make it paywalled. But we know that, and from studies, if you monetize an application in the early growth phase, what will happen is you will lose like 70% of your growth potential. And so instead of going up in this exponential rate, and that's important because a lot of these applications, they do spread exponentially. They don't spread linearly. It's not like you put money into advertising and then more people come. It's that people bring more people. And that, as we all got a lesson from the pandemic, has sort of, the math of it is quite important. So if you put it in pandemic language, you see that, well, an application like Twitter has an R0, so the replication rate for each user, that user brings more than one extra user. So say 1.6. And that means that over time, the thing spreads very, very quickly in the society. Well, that happens, just as much with viruses as it does with computer services. But if you cut the growth potential of your web application by 70% on day 5, well, you're going to go from a 1.6 or a 2.5 R0 to below 1, and then you fundamentally do not. It's like a binary. Like you either spread across the whole set of people that might be interested in the project, or you don't. And if you cut the growth potential like that, there's a very high likelihood it just won't be viral. So it's pretty fundamental. You can't really go that route at the beginning of an application. So, well, the people that are successful, typically, they go the opposite route, and they say, okay, well, I can go take this application to venture capitalists, and I can say, hey, look, people really like to use this application I've built, but I can't pay for the server fees, and I want to grow the application too. I want to invest money in providing a higher quality service to people. And they say, yeah, sure, that sounds pretty good. And essentially what they do is they bankroll the process of capturing the market. So during the second phase here, market capture, the quality of the application is improving. More people are finding it, and they are getting, one way or another, locked into using an application. This is tricky because at the same time, as the founders go through this process of professionalizing the organization to some extent and growing it, they also lose control. They lose control of the board, they lose control of the shares, until the point where the people that had the vision at the beginning aren't necessarily the people leading the decision-making. And finally, we get to the third stage, which is profit maximization. So after you've captured the market, the complete market, everyone that is interested in the application is already using it. And there is some sort of moat. There is something that keeps them there. They can't easily leave. Well, then naturally, and this is really very understandable, the people that are now running the board of the company, they want to switch to a mode that maximizes profit. And so they do. And from the user's perspective, this means that either there's now like intrusive ads, or their data is being sold and it wasn't previously. Or in the case of Medium, for example, their articles that they had written that were being distributed to an audience that they had curated are now being paywalled. And that pay is not going to them, but it's going to Medium, the company. It happens almost every time. So this is pretty fundamental. In PermaWeb applications, it's not like this. The relationship between user and developer is fundamentally different. The user can come back to the application because the developer can't change it after posting it to the network. It's got a TXID once it's settled in the network. They can come back to the application at any point in time and use it if they prefer. And so now, if the developer says, well, hey, I want the users to come along and use this new version, well, sure, you can do that. You can release a new version. You can even change the DNS name to point to that new version. But you can't stop people using the old version if they prefer it. And so now, every time you update the application, you can't perform what we would call a coercive update. It has to be voluntary from the user's point of view. And subsequently, each new version has to increase the quality than the old version. And if you want to add ads, which you absolutely can, then you have to make an equivalent amount of, or a higher amount of, quality improvement for the application in another way, such that it's worth people's while to upgrade. And so this changes the power dynamic, again, between user and developer, such that they can be confident that the application is frankly not going to screw them later, which is a totally different game. And so here's Weavemail as Lev. Lev is a core Arweave protocol engineer. We built this web application. It's an extremely simple protocol to some extent, which we'll get into in a second. But it's a web application that's hosted on the network. You see weavemail.app in the URL bar here, but there is actually a TXID underneath it, and you can find it fairly easily. You can go to this, and it's in exactly the same state as it was literally, I guess, 3.5 years ago now, when we first built it. It runs precisely in the same way as it did back then. There's nothing we can do as the people that launched that application, which has now seen a fairly significant amount of use. There's nothing we can do to extract money out of it, unless we were to improve its quality. So from a user's perspective, there's no chance that this startup's going to go bust and the service is going to disappear. There's no chance that they're going to, if they don't sell your data today, they're not going to sell your data tomorrow. Like, you can use this in a really robust way. Okay, you can build applications with the system on top of open data. So when a user builds, or when a developer creates a PermaWeb app, their users typically contribute their data through something we call a data protocol, which is essentially a set of tags on top of a piece of data. And they send it to the network, and then it's accessible for everyone. And so you, as a developer, can build on top of the data that is housed inside Verto, or inside Mirror.xyz, or inside Agora, which is actually now called MetaWeave. Or in the case of Weave.mail, you can use the data from PermaMail, this data protocol we mentioned. So here we have a new user interface that someone built. And this is still, like, I guess now probably 2 years old, something like that, approaching 2 years old. This is a new UI that has access to all that same information. It's kind of like the PermaWeb itself is a data lake, and any application can pull out data from users and display it in a new way. So as you can see here, the WeaveMail UI is substantially better than the original WeaveMail.app UI that Lev and I made in an afternoon. That's great, and they have a profit sharing token inside the system that sends a tip every time you use it to the person that built it. Well, it's a better version of the application than the old one, and so they have every right to collect fees on it, and people use it because it's better. Yes, and so you can access on top of the system a wide range of data that can pre-fill your UI, if you will. So when you build on top of the PermaWeb, you don't have this problem of like the cold start, as they call it in the traditional Web 2 startup world. But basically, imagine you're trying to build a new Twitter. Well, on day one, there's no posts. Well, you don't have that problem with Arweave. You have everything that is a similar application. You can just pull its data into your UI, and it's pre-populated. And if it looks nicer and it feels better for the user, they will use it. And so there's an open data system inside the network. Okay. You can build applications on this network that take zero maintenance. So I showed you previously a screenshot from WeaveMail.app, the original UI that Lev and I made, where we paid I worked this out once, is about 1/100 of a cent to store that UI at the beginning. And we haven't paid a single cent in maintenance, nor have we done any work on it. It just still works. And how does that function? Well, the relationship between developer, code, infrastructure, and users is different in Arweave. So in a traditional web application, the developer basically provisions some services like AWS or Heroku or whatever it happens to be, where there are servers, and they deploy their code onto the servers. And so there's a tight bundling of the code and the service itself. And from the user's perspective, they just access the service. It's all one big like black box, can't see what's happening, but it just kind of works. And that means that the costs and the power accrues with the developer. Well, in Arweave, it's different. We've dissociated the source code of the application from the infrastructure on which it operates. And so now the developer, that would be in the case of WeaveMail.app, that was Lev and I, we pay to post it to the network. Now we're done. That's it. We don't accrue any further costs. And then when the user wants to access that information, they go to, in this case, Arweave.net, or they could go to Arweave.live or some other gateway, and they have a financial relationship with that gateway, one way or another, that makes it worth the gateway's while to render that source code, if you will, into an application experience that feels like a normal web app to the user, but in reality, something very different is happening. And there's a million different ways you can do this monetization step. So at the moment, Arweave.net is just free because we, the Arweave core team, have an incentive to operate it. But in the future, you can imagine, we don't have to imagine very much, I think this is coming down the pipe right now, gateways that offer premium services, so faster access, or gateways that are, ad subsidized, this kind of thing. So that infrastructure component has its own monetization system that ensures that the developer doesn't accrue the costs. All right, so that was a lot of information. I promise we're nearly there. Fortunately, the how you would build these applications is extraordinarily simple. If you can build a simple JavaScript web application, you can build on the PermaWeb. This isn't hyperbole. really, we've tried to keep it as close to normal, simple web app development as we possibly could. You build precisely as normal, but when you want to have user accounts or something like this, you just use Arweave.js, this library that the community has built, or rather we built first and has been forked by the community and has taken on life of its own to interact with the user's wallet. And this, remarkably, can actually save you time and complexity when you're coding. So instead of having to, keep some sort of database of people's username and make sure that you're actually deriving, password hash properly so that you don't end up on like a Hacker News as yet another company that didn't do password derivation properly and now everyone's passwords are public. You don't have to worry about any of that stuff. You just say, oh, okay, get me the user's username. And if the user doesn't have the wallet installed, it pops a thing that says, hey, please go install a wallet and guide them through that process. Or if they have a wallet, it pops a little button a little, what do you call it, popover like this, actually slightly different screen. It says, hey, this application wants to interact with your wallet. It wants to do these and these things. Is that okay? You press yes. And unlike MetaMask or similar systems, you can set an what do they call it? An allocation or something like this. An allowance. You can set an allowance for the application. Say, look, I don't want to press yes every time this application because it's storing data. It's not sending money around. Every time it stores a tweet, I don't want to have to press 2 buttons in this UI. Just say, remind me the next time it has spent more than $1. And that, for almost all PermaWeb apps, you'll never see that thing again. And so it just acts like you're logged in, and the user experience is extremely smooth. You don't even realize they're using a sort of Web3 application. But in the background, their identity is self-sovereign. So this wallet you see here, VLRHF, whatever, that's my account on the PermaWeb essentially. And I can move that wherever I want. I'm not locked into any service. I own it just like you would own an account on Ethereum or Bitcoin. One final thing with this, we actually recently added a system whereby the Arweave core team, working with Bundlr, are subsidizing transactions less than 100 kilobytes. So if you have a new user to the PermaWeb and you're like, I don't want to make my users have to go and buy tokens in order to get on board with my application. That's crazy. Don't make them do that. Just generate a wallet in the application, let them download it, and then you can use that wallet to start sending data to the network. And if it's less than 100 kilobytes, we will subsidize it to start with. And going forward, we expect that there will be gateways that will subsidize user fees up to some small amount too, because they're going to show some ads, or they're going to have a financial relationship with the user one way or another that is not represented in crypto necessarily. Like the user might top up $5 on their account, and then when you send a transaction, they will pay for it. The gateway will pay for it on behalf of the user. And so this makes it so that you can onboard users to PermaWeb apps that have no crypto experience. Just need to guide them through the process of understanding that their identity is a wallet rather than a username and password. That's it. Or if you want to add support for people that are from different ecosystems, perhaps from Ethereum or from Solana or Avalanche or Near, really, and all the ETH layer 2s like Polygon, Optimism, really essentially any of those ecosystems. If you use Bundlr with Arweave, you can, it's the same sort of delegated payment system that I was describing. But here you can have the user pay in their Ethereum tokens. Well, that's actually one you might not want to do because the fees are so high to deposit that you just be paying the Ethereum chain basically to send the transaction. The cost of data storage on Arweave would be so tiny in proportion to it, it doesn't really make sense. But on an L2 for Ethereum or on Solana or on Avalanche, then they can pay with the local currency of those chains to Bundlr, and then they can sign their transactions and they can send them to Bundlr, and they will pay, the Bundlr nodes will pay on behalf of the user. And so from the user's point of view, it just feels like they're using Solana or whatever it happens to be. But in the background, of course, they're building or they're using a properly decentralized web application rather than just a smart contracting system. Okay, instead of using a backend database, like a MySQL, Postgres, whatever it happens to be, you use GraphQL instead. And there's a simple API for this that essentially looks like this. So if we wanted to find every transaction from a user interacting with a network, which is text HTML, and it's someone uploading an automatic archive of some sort. Auto DPL was this automatic archiving system. Then you can just run this query and you post it at the gateway, and the gateway will return a set of TX IDs for you. Or it will return, so here at the bottom you can see we're selecting the ID from the responses, but you can also select the wallet address, any of the sub-information about that transaction. So GraphQL is a fairly well-used system, but if you're used to MySQL or something like that, then there is a small amount of learning to do, but really it's quite easy to get on board with. Okay, final step, you've built your application, that's great. You want to deploy it. Well, instead of deploying to Heroku or provisioning a server in AWS, you just use Arweave. So you yarn global add Arweave or npm, whatever you want, and then you just say Arweave deploy, and then in the directory, and then use Bundlr, and you specify a Bundlr node, which we do this here, but I think there's actually a default, so you can probably drop that argument, and then you specify your wallet, your Arweave wallet, which you can generate from that Arcanate web browser, or I think Arweave also will make one for you if you want. And you just run this, and it will go. And if you use the right Bundlr node, it will even do this even if you don't have any tokens on Arweave. So you can deploy with no cost to you, essentially. And then your users have access to your application forever. It's a pretty, well, we think it's a pretty neat system, but I must say we're biased, I guess. Or if you don't like the command line so much, you can just use this thing called Argo. I think we actually rebranded to Spheron. But if you search Argo app, you'll find it. Yes, which is a sort of GitHub integration that you can press a button in GitHub, and then you can deploy your application to the PermaWeb, and then it will automatically update as well your DNS record to point to the new version that you've just deployed. So it's a very, very simple system. Okay, final component. Well, so you built this application, but you want there to be some form of governance. You don't feel like you can have it just be a sort of open speech platform. Fair enough. So how should you do that? Well, there's this thing called community.xyz, which I showed you a quick screenshot of before, but in a little more depth. It's basically a DAO management platform built directly on top of the PermaWeb using smart contracts that live on the PermaWeb stack. And yes, you can vote on things that are appropriate for your community, like even, for example, here, yes, the number one here is setting a fee. So the community that has one way or another become staked into owning the application, they can vote together on what the fees, what sort of individual parts of the application should, how they should operate. So here they're setting a fee, but it could also be, we would like to set this content policy. So we want to block this type of information, but not this type of information. And you can vote as a community on that. And then using the system called Community.js, it's just a really simple way of interacting with the DAO from directly inside a web application. It's literally like one line to include it there, the minified version, as you can see at the bottom. Or you can, once you have that, then you can just say, hey, Community.js, tell me, what did our community vote on as being the highlighted post of the day? Something like this. And then you can vote to give new tokens to people for great contributions and all sorts of things using this very, very simple interface. All right, that was a ton of information. I hope it was helpful. If you want to know more about how to build on top of the PermaWeb, just go to rwiki.wiki, which is, of course, a PermaWeb application itself run directly by the users. If you contribute there, you will be minted new Arwiki tokens, and they give you the ability to stake and elect moderators of the system. And of course, we as the people that built it, actually, Ricky from the community did the bulk of the work. we have no privileged power on that system. It is purely community operated. All right, thank you so much. Yeah, I'm excited for the conversation in the Mingle area. Oh, and please do remember to come along to the session we have on Friday. These community spotlights are really, I'd say, like, well, I don't want to diminish the rest of it, but one of the highlights for sure of the Open Web Foundry program. It's an amazing way for you to meet other people that have been building on the network and see how you can integrate with the things that they've created and get this sort of, well, as I was describing there, that open data leads to combinatorial success of everyone in the ecosystem. All right, see you in the Mingle area, everyone.
See you guys.